we're going to be writing the tangent ratio from a diagram. So remember, with the ratios, you want to use the fraction form. They do need to be simplified, but all it is a ratio. If you're asked to write the ratio, then once you have it, you simplify it, you're done. So we are going to write the ratio for the tangent of t. So we're talking about angle t. Remember, the tangent ratio is the opposite over the adjacent. So you go to angle t, and we have to determine what side length is the opposite. So what would you say is opposite of angle t? What side? UV, which is 3. Okay. So on top, we're going to put 3. And which one would be adjacent to t? TVU. So adjacent to t would be what? TV, so 4. So the ratio for the tangent of t is 3 over 4. Right? It can't be simplified, so that's it for the ratio. If we do u, the tangent of u, again, is still tangent is opposite over adjacent. So what would be opposite for angle u? TV, which is 4. And adjacent to u is UV, which is 3. So you'll notice that depending on which angle you're talking about with tangent, they are reciprocals of each other. Okay? So applying this so that we're actually using the ratio, so you can write down using the ratios, or the ratio to find a side length. You're always going to go back to, and it doesn't matter once we do sine and cosine, you're always going to go back to the tangent of the angle equals opposite over adjacent. So it's kind of like in a little equation that you're going to fill in what you know. So we want to say the tangent of the angle equals the opposite over the adjacent, and you do need 2 out of 3 pieces of this equation to solve for one of them. Remember, tangent of the angle is a package deal. It represents a number, okay? So in the first example, we're going to have a 54-degree angle, a side length of 10, and we're looking for the other side, which is W. So we're, with just these 2 pieces, we're going to be able to find another side. Obviously, we could find the third angle without trig because they have to add up to 180. But you could find the other 2 sides using trigonometry. Okay. Specifically here, we're using tangent to find W. So filling in what we have, you're going to say the tangent of 54 degrees. So we're replacing the angle with the angle measure. Equals, well, what is the opposite for 54? It's W over the adjacent, which is 10. Okay, so once you have it set up, that's half the battle, but in order to solve for W, we've got a little bit of algebra to do. Now, you're not going to split these 2 up. This is a package deal. Again, the tangent of 54 represents a unique number, but to get W by itself, what do you need to do? Multiply both sides by 10. Now here's where the calculators can be a little bit different. If you have the type of calculator that allows you to put in 10 tangent 54, you can enter it just like that. It'll give you the answer it should be 13.8. So W should be 13.8 when it's rounded. If you can't put that all in at once, then you kind of have to back your way out of it. So you would put in 54, hit the tangent key, which will give you a decimal, and then multiply that result by 10. So you want to keep leaving that decimal answer in your calculator as you apply the next operation. Otherwise, you're going to end up with a pretty significant rounding error. The more we round and use it and round and use it again, your answer gets further away from what it should be. Okay. Now, one of the things that I want to point out is 13.8 is a side length. So, since it is a side length, if I put it back over here, if that length is 10, would it be reasonable to say that the other side would be 13.8? That seems like a reasonable amount. So look at your answers. If you got like 0.6 as a side, you might want to go, oh, wait a minute. That doesn't seem reasonable. That seems a little bit too small. So you'd want to go back and check some things. Okay. Could just be that you punched something in wrong. Maybe you put things in the wrong place. Okay. So we're going to look at a couple more examples.